Wendy is evaluating a capital budgeting project that should last 4 years. The project requires $800,000 of equipment. She is unsure what depreciation method to use in her analysis, straight line or the 3-year Maker's accelerated method. Under straight line depreciation, the cost of the equipment would be depreciated evenly over its 4-year life, and we're going to ignore the half-year convention for the straight line method. The applicable Maker's depreciation rates are 33%, 45%, 15%, and 7%. The company's weighted average cost of capital is 10%, and its tax rate is 40%. Part A asks, what would the depreciation expense be each year under each method? Okay, now you see the solution to Part A. So under the straight line method, you see that it's just $200,000 depreciation per year, and that's $800,000 divided by 4 years, right? $200,000 each year, and we're ignoring the half-year convention for straight line method, which is a tax treatment. Okay, and then under Makers, we simply take the $800,000 and divide it by the appropriate percentages, and you get the answers that you see right here: 264, 360, 120, and 56,000. All right, and that takes care of Part A. Next, it says on Part B, which depreciation method would produce the higher NPV, and how much higher would it be? Okay, and now you see the start of the answer to Part B on the bottom portion of the screen. First, we calculate the depreciation expense difference, and this is just the difference between scenario 1 and 2. So, as an example, the first year, under Makers we had $264,000, under straight line we had $200,000, so the difference is $64,000. And then we do the same thing for all 4 years. Now, under Makers, we're in a 40% tax bracket, which was given right here in the problem. So if we multiply the number in this column, right, this column here, times 40%, we're able to come up with the depreciation expense difference would be after taxes. All right, let me explain a little bit why that is. You can't just subtract depreciation expense from each other because there's tax ramifications. So normally depreciation expense is subtracted from revenues, right, to come up with operating income. It's one of the expenses like any other. And then taxes are computed after we know operating income, and then we have to add back depreciation to obtain the project's operating cash flow, right? Because depreciation is an expense that does not require cash. Therefore, if the tax rate is 40%, only 60% of the depreciation expense is actually subtracted out during the after-tax operating income calculation, and then the full depreciation expense is added back. So in other words, the 40% represents a tax benefit or a tax shield associated from having depreciation expense. All right, so the difference between depreciation expenses under each scenario needs to be multiplied by the 40% tax shield to determine the benefit provided by the depreciation expense. Okay, and finally it says what depreciation expense would produce the higher NPV and how much higher would it be? Now I've rearranged the screen a little bit. I removed the solution to Part A and then moved solution to Part B up a little bit. And then I've dropped in those numbers that you see right here into Excel. And this actually is Excel in the background. And in fact, I just turned on the grid lines so you can sort of see that I'm working in Excel here with some images on it. All right, so here's our numbers: 25,000, 64, 32, and 57. These are these numbers you see right here. They tell us that the appropriate rate, the weighted average cost of capital, is 10%. So all we have to do is calculate the NPV. So I'll type in NPV, I'll hit my left parenthesis, and then down here we'll just put in the information. The rate is in that cell, and then I'm going to list the values which occur at the end of year 1. So I'll just highlight that down, close the paren, and hit enter. And I come up with the answer of $12,781.64, and that is the answer. That tells us that in the analysis here, that if we use accelerated depreciation, it will result in a higher NPV by $12,781.64 than what would be the case if we use the straight line depreciation method.